Here, quiz 5 solutions for Math 111. In this first problem, there's actually two parts to it. We're given two different functions. There's the other one down there. And for each function, two different x values, and asked to find the average rate of change. To even have a chance here, you have to know what average rate of change is. What it is it's the change in the y coordinates divided by the change in the x coordinates, kind of akin to slope, I guess, if you want to think about it that way. Fortunately, the problem gives us two different x coordinates. So if I want to do x2 minus x1, I got 3 plus h minus 3. What I need to know are what are the corresponding y coordinates. I need to know what's y2 and what's y1. Well, y2 is just f of x2, and x2 is 3 plus h. F of 3 plus h, it says take your function and everywhere you see an x, change it into a 3 plus h. So what I would get is 3 plus h over 3 plus h plus 2. In other words, 3 plus h over maybe 5 plus h. Similarly, for y1, I'd want f of x1. x1 is 3. So what I now do is I take f of x, and everywhere I see an x, I change it into a 3. So it's 3 over 3 plus 2. In other words, 3/5. So over here, I can say y2 is 3 plus h over 5 plus h. And from that, I want to subtract y1, which is 3 over 5. This is correct, it's just not simplified, but it is the average rate of change, this mess right here. If we want to simplify this, what we got to do is take care of kind of these fractions inside fractions. So I think the easiest way to do that is to find a common denominator in the numerator of the big fraction. So instead of 3 plus h over 5 plus h and 3 over 5, what I can do is I can multiply this side by 5 plus h over 5 plus h, and this side by 5 over 5. And what that will do is will give me a common denominator up here in the numerator of this big fraction. And the denominator of the big fraction, 3 plus h minus 3, that's just h. So what I get is 5 times 3 is 15. 5 times h is 5h. And then over on this side I have minus 3 times 5 plus h. So minus 15 minus 3h. And that's divided by 5 times 5 plus h. And that's all divided by h, or if you want to think about it as a fraction divided by a fraction, we can think about it as h divided by 1. It'd be easy to forget this minus right here. I'm subtracting this entire thing, so it's really the negative 3 that gets distributed into these parentheses, which brings me here. If you clean this up a little bit, 15 minus 15 is just 0. 5h minus 3h, that's just 2h. So I get, how should I write this? 2h over, you could distribute the 5 in if you want, or you could leave it out like this if you want. It really doesn't matter. What I now have is a fraction divided by a fraction. Really, it's a rational expression divided by a rational expression. And the way you divide fractions is like multiplying fractions, but you multiply by the reciprocal. In other words, flip this thing upside down. Change it from division to multiplication by flipping this upside down. What happens now is I have an h here and an h here that can cancel each other out. So what I get for my final simplified answer is 2 over 5 times 5 plus h. And maybe I'll even say, or 2 over 25 plus 5h. I don't care which one of these two you use. Either one's totally fine. Simplified is kind of subjective. Yeah, I guess that's good. That's the answer there. Now do it again. Kind of tedious algebraically, but okay. Gives me a new function, g of x. So again, my average rate of change is y2 minus y1 over x2 minus x1. I have x1, I have x2. Can figure out y1. y1 is just, I guess, g in this case. Maybe I'll do this somewhere else. Let's do it off to the side here. y1 is just g of x1. x1 is a. G of a is negative 2 over a. y2 is g of x2, which is a plus h. G of a plus h is negative 2 over a plus h. So back over here, when I'm trying to figure out the average rate of change, I just plug in all those values. y2, negative 2 over a plus h, minus y1, negative 2 over a, divided by x2, which is a plus h, minus x1, which is a. Now we can clean this up a little bit. Negative 2 over a plus h. Instead of minus and negative, how about we just make that positive? Might make life a little bit easier. A plus h minus a, just h. The two a's cancel out. So you get to here, which is kind of similar to this stage here, where we got these fractions inside fractions. If we want to combine these two fractions, we need a common denominator. To get a common denominator, multiply this side by a plus h over a plus h, and this side by a over a. And when the algebraic dust settles, you get negative 2a plus 2a plus 2h divided by that common denominator of a times a plus h. Guess I'll just leave it like that to be consistent. And then that whole thing is divided by h. But you'll notice you have negative 2a and positive 2a. Really, you just have 2h left up top there. And then instead of thinking about this as h, you could think about it as h over 1, because that'll make it easier to divide the fractions if you view this as a fraction. Like we saw above, the way you divide two fractions is kind of like multiplying, which you multiply by the reciprocal. Instead of h over 1, it's 1 over h. What you'll now notice is I got two h's that cancel each other out. And what I am left with for my final answer is 2 over a times a plus h. Probably the trickiest part here is, if you deal with these negatives early on, it makes it a lot easier. If you wait a while, it might make it easy to mess up a negative sign somewhere. But, that's minor stuff. If you missed a negative sign somewhere, you're not going to get killed grade-wise. But, I don't know, maybe pick it up next time. Still not done. Another problem. It says, I have a function h. It's graphed down here. Here it is. This is h. Okay. Describe in words the transformations that would turn h into this mess right here. So look at this mess right here and tell me what all these transformations are. Specify the order also. Well, kind of have two different kinds of transformations. We have vertical transformations, and we got horizontal transformations. This 2 right here is a vertical transformation because I'm multiplying it by the h of x, and it's a stretch by a factor of 2. This negative 1 is also a vertical transformation. Did I say vertical over here? I meant vertical if I didn't say vertical. It's a vertical transformation. This is a vertical transformation. They both go over here. But what order? With vertical transformations, you do the multiplication before the addition. So the first thing we want to do is we want to stretch vertically by a factor of 2. Second thing we want to do, take care of this negative 1, shift maybe down by 1. Over on the horizontal side, we have two different types. Kind of have this negative 3 here, which is going to shift us to the right by 3. And this negative 1 in front of the x, which you can either think about as stretching by a factor of negative 1 or flipping horizontally. It's important that you do the minus 3 first. So the first thing we want to do is shift right by 3. And the second thing we want to do is stretch horizontally by a factor of -1. Maybe I'll put AKA flip horizontally. Something like that. So we have 4 transformations we want to do. This is going to get kind of ugly, but all right, I'm going to take care of the vertical ones first. Stretch vertically by a factor of 2. What that means is take all the old y values and multiply them by 2. So this y value used to be 1, now it's up here at 2. This one used to be 2, now it's up here at 4. Sorry about that. This one used to be 1, now it's up here at 2. This one used to be -2. -2 times 2, it's down here at -4. That just took care of the first step. Now I want to shift down by 1. So this point shifted down 1 ends up right back here. This one shifted down 1 ends up right here. This one shifted down 1 ends up right here. And this guy shifted down 1 ends up right here. So what I get is kind of this shape. Maybe it's time to outline that a little bit. And you could outline the blue one too if you wanted to, but I'm going to have a lot of different steps, so I don't want it to get too confusing, more than it has to. What I've now done is taken care of the vertical transformation. I want to take care of the horizontal ones. Shift right by 3. All right, this point right here, 1, 2, 3. Move over to here. This point right here, 1, 2, 3. This point right here, 1, 2, 3. And finally, this guy down here, 1, 2, 3. Gives me something that looks, roughly speaking, like this. I'm almost done. I just have one step left to do. Running out of colors, so I'll go back to blue. That's a bad idea. Let's change it into black. Last thing I want to do, stretch horizontally by a factor of 2, aka flip horizontally. I think it's easier to think about it this way. Take all the old x coordinates and multiply them by -1. This guy used to have an x coordinate of 0. 0 times -1 is just 0. This guy used to have an x coordinate of +1. +1 times -1 is -1. This guy used to have an x coordinate of 1, 2. +2 times -1 is -2. And finally, this guy over here used to have an x coordinate of -1. -1 times -1 is +1. So, I don't know, maybe I'll make these bigger. For my final answer, I end up with this guy, this guy, this guy, and this guy. And if I kind of connect them, trying to keep the same basic shape as I had before, something that looks, roughly speaking, like this. These are really hard to draw on a computer. Call that good. Shade it in so it doesn't look quite so ugly. Or maybe I'm just making it worse. Maybe you don't care at this point. Good enough. This thing right here is my final answer. That's the end of this quiz. Kind of a hard quiz if you ask me. Yeah, that's the end.